I'm going to talk about Lucene payloads and Solar, but I'll just first tell you who I am. My name's Neil Hui, and I work at the search team on Shutterstock, and I've got a couple team members here as well. It's a stock photography company, and we're hiring. Oh, and then the website. Here's our website. We've got search up here and photos, and these are kittens. So that's that. Okay, so ranking. For ranking, TF-IDF is pretty good for most cases, text documents and such. But at Shutterstock, we just have photos that have metadata. And the most relevant stuff in there is a set of keywords, of which there's no duplicates. So something like term frequency isn't relevant. Yeah, so keywords, tags, and those sorts of things. There's the option to do per field boosting. So you can sort of assign a boost to an entire field. So for one document, you could say the keywords for this photo are pretty relevant, and the keywords for this other photo are kind of spammy. And then you can rank your documents based on that entire field's boost. That's basically what I said already. So for this banana here, let's say he's got keywords food. He's not really food, but I have other keywords that are more relevant, like yellow, face, and toy. So overall, I'd arbitrarily give it a boost of 3.5, because one of the words is not that relevant, the others are. For this photo, let's say it's got keywords food, which it is, and then other ones like delicious, vegetable, and delicacy, which certainly are not relevant. And at Shutterstock, we get this happening all the time. We have contributors who take photos, and they make money from their photos being downloaded, so they're sort of incentivized to spam their photos with irrelevant keywords. So we have this problem. So I give this one a boost of 1, because it is food, but it's not the rest. So if you do boosts on the entire field, there's some limitations. You're doing an overall score on the relevance of all the keywords in this case. And that's sort of depending on what you're searching for, it's not going to work all the time. So in this case, if we search for food, his boost will be 1, so it won't actually match that well. Whereas the banana has a high boost, but it's not actually food. So the banana will be ranked higher even though it's a toy. It's just one example. It doesn't consider individual values, so therefore you get things like you can't say that this is greater than that for the entire keywords field. So what do? You need the score based on terms searched, and having per field value boosts is handy, and that's where payloads come in. So payloads are basically per field value bursts for multi-valued fields. So you can do something like associate keywords with behavior metrics. So you could take every single one of those keywords in a multi-valued field and give them all a score based on whether when somebody searched for a specific keyword like banana, did they actually download the photo? And you would boost up that keyword based on that sort of thing. And other search metrics you can use. So just give another example. Let's say we boost all of their individual keywords like this. And for spam, we'd boost them all like this, where we're just giving 0 to those irrelevant keywords. And then you'll tend to get better results. So how to use payloads in Solar? Well, it's not directly supported by Solar. It's a feature in Lucene. So you need to overwrite some Java classes, which is pretty fun. And you need to make a new type in the schema, which is a payload type, and start converting your multi-valued fields to payloads. So you basically just take a list of keywords and put it into a paragraph. And up here we've got food bar 0.5. That's the keyword and the payload beside it. And in this example, they're tokenized on spaces. You can tokenize on anything else you want. You just have to change the tokenizer. So we prepare the fields like this. And then here's adding a type in the schema. So up here we've got payload term tokenizer factory, which creates a payload term tokenizer. You also have to include delimited payload token filter, various things like that. I've changed the tokenizer as well. And you have to define your own similarity class, which is payload similarity. So that's how you change the schema. Here's an example. So there's a query. It just says def type equals payloads. And I'm searching the keywords field, which has been changed, as I said before. And it'll return. This is the explain part of the debug query. And you can see it's using payload similarity up there. And you get a payload score down there. That's how you do it. You've got to also override some Java classes. And I found that not many people actually use the payload feature. When I asked in IRC and on the mailing list, a lot of people sort of knew about it as if it had been this thing from a long time ago. So I went and figured this out. And here's a very complicated diagram on how to do this. OK, so here's a lot of the classes. OK, it's not that bad, but you basically have to go and you return a term query at the end with all the Solr query parser and stuff, and you just replace a couple. You make your own Lucene Q parser. You make a Solr query parser. And you just override new term query to get it to return a payload term query, and you're done. So it's kind of a mess. But the performance is OK. We managed to get it. It's slower than term queries. I had term queries going about 700 queries per second on my machine. And we managed to get it going at 200 queries per second. So it's not that bad. No dupes, warmed, and index in memory. And that's pretty much it. So if you're looking for this feature, if you're trying to do the same thing, Payloads is a really good way to go. And I sort of plan to write payload support directly in the Solr so you don't have to do that whole massive overriding. And that's it. Thanks.